Good morning. So the paper that we have is Multilingual Denoising Pre-training for Neural Machine Translation. So as for introduction, mBART follows BART architecture, but it is trained on a different type of setting. So the problem that BART faces is that for different type of languages, we need to train different models. mBART provides a solution to that. The objective of mBART is to infuse transfer learning for low resource languages that can be helpful. So what BART does is it takes a corrupted text and tries to regenerate that text through the decoder. So this is an autoregressive model. Earlier we have seen BERT-like architectures where we only have encoder or decoder type of models which are trained to understand the language sentiments, and then they can be fine-tuned over different architectures for different downstream tasks. But BART allows a autoregressive model that can be fine-tuned very easily without adding much of architecture. So mBART is just a variation of BART with a different type of setting that it is trained on. So we'll see the architecture now for mBART. We have 12 encoder layers, 12 decoder layers, and in each encoder layer we have 16 attention heads. And also one additional thing is that after encoder and after the complete decoder, we have one layer normalization set each for encoder and decoder. So the pre-training objective is, firstly, the languages we have mBART takes us 25 languages from common crawl. So it's so different type of languages can be in different amount. So just to balance that out, it uses this particular formula. What this formula does is for higher percentage of languages, it kind of scales that language down. So let's say for English we have 90% of the data available. Let's say for example, then it would scale down to some constant number so that each language has some equal number of sentences that can be drawn from them randomly. Also, important thing is that smoothing factor they have taken as 0.7. So, for tokenization purpose, they have used sentence piece tokenizer on the common crawl dataset, and this is a common tokenizer that they have used for all 25 languages, and hence they have so many server tokens, 250,000. So, mBART is trained to reconstruct the original text from corrupted text as BART did, but this is trained on multilingual setting as we'll see in future. So there are two types of noising function that it uses. Firstly, it permutes the sentences, the order of sentences. Secondly, we'll also see how the instance look like in the coming slide. But for now, let's understand what is only the noising functions. So firstly, the sentences are permuted. For example, let's say I am a cat and I like drinking milk. So that sentence will be flipped around and it will be like I like drinking milk, I am a cat. So this is the first noising function. The second one is masking. 35% of the words are masked by randomly sampling a span length with lambda is equal to 3.5 from Poisson distribution. So let's say the output comes out with 3. So 3 words would be masked. So 3 words would be removed from the sentence and a mask token, a single mask token would be placed there. Now we look at the instance format. So what it does is it randomly samples sentences from a particular language ID. It selects a language from which it has to sample, and then it keeps on sampling the sentences until it hits the 512 token length limit uh, or the document is empty. Each sentence is separated by a separator token, S token, and now we'll see the learning objective. So we have the K languages, 25 in our case. What it does is we aim to maximize the likelihood of this particular thing parameterized by theta. So what it says is that we want to maximize the likelihood of getting the original text back given the character text. So this objective is kind of same as BART, but for multilingual settings. They have trained different models for just checking that how many languages should be pre-trained on and these kinds of factors. So mBART 25 has been trained on 25 languages, whereas mBART 6 is trained on just six similar type of languages to understand how language transfer works for similar languages. These are just European languages, just for understanding. mBART 2 is another model that they have trained for these three particular pairs: English to Dutch, English to Romanian, and English to Italian. English BART, a single English and Romanian corpus is also for baseline purposes trained. Now, after pre-training, we come on to fine-tuning and decoding. So, once the model has been pre-trained, uh, fine-tuning is done for, let's say, a task like machine translation, where uh, given in the encoder a particular text of a particular language, let's say from English, the output comes out from another language outside the decoder. So what happens is encoder takes English sentences and it creates embedding for them, and those embeddings along with the language ID goes inside the decoder to generate a particular one token for another language, let's say Romanian. So that word which is generated for the decoder by the decoder, that again goes inside the decoder to generate a second token, and hence we translate the given English sentence to Romanian sentence. For low pair sentences, we have done training steps. We have updated for 40,000 updates, and for large resource based pairs, we have updated the pre-trained model 100,000 step times. So this is probably because this is solely because to avoid overfitting for low resource languages. For decoding, it uses a beam search. So rather than taking just the most probable word, it takes five most probable words and kind of creates tree uh, around it, so that we select the most probable sentence and not the most probable word. Back translation is also done for low resource pairs. So let's say we have very low resource pairs such as Gujarati and English. So we do not have too many language pairs for them. So what we do is we take the larger language such as English. We use that model to create synthetic data for Gujarati, and we use that synthetic data to fine tune Gujarati to English channel. So now we'll see the experiments and results that the model has to offer. So one important result that we can see is that for low resource languages like English to Vietnamese, only 133,000 pairs, we can see there's a huge improvement from randomly initialized model to a pre-trained mBART 25 for 25 languages. So this probably proves that uh, pre-training for a multilingual setting kind of becomes essential when we're doing some multilingual tasks. Another important thing that we see is that for very low resources like English to Gujarati, we, we both of the model fails because this is for obvious reasons, because the model is not able to learn the important relationship between languages due to the lack of data. Another important thing that we can see here is that for high resource languages, model kind of uh, gives the output same as randomly initialized BART 25. This is because if randomly mBART 25, what it can do is that while pre-training, it can take uh, noises from various languages, and hence it can perform than uh, poorer than the randomly initialized model for for high resource languages. So now we'll see comparison with other models. You can see all these are only encoder or only decoder based models. So uh, they do not perform as better from BERT 2 and 25. This is because they had to train a complete decoder or complete encoder after pre-training, which generally is equivalent to training a model from randomly initialized weights. So we can see one important comparison that we can see is that mBART, BART English can be compared with BART because both of these are auto-regressive models, but still we can see improvements from Romanian to English tasks, because what we can infer that uh,
while pre-training mBART2 or mBART in general is that it kind of learns the intra-language relationship. For example, it learns the grammar of English, Chinese, and so on. And while fine-tuning, it has to just learn the relationship among languages, how English is related to Chinese, how English is related to Romanian, and all. While mBART English has to learn both of these tasks while doing the same thing, while fine-tuning. Another important thing that they have showed is information transfer. So transfer learning was not possible before mBART. What they have showed what they have showed is that if I can fine tune a model for a language pair X to English, where X is any language, let's say Romanian to English, then we can test it on some other language, let's say Japanese to English, and the result would they are claiming that the result are very good. For example, let's say for randomly initialized model, we can see that blue score is almost zero. But for here, what we can see is that for similar languages like Hindi, English, and Gujarati, not English, Hindi, Gujarati, and there's Nepali, which are Indic languages. So what we can see is that once we train the model from Hindi to English, it can very well perform the Nepali to English translation. So this was not possible before mBART. So mBART has kind of infused transfer learning, and this is the first model that has shown such good results for that. So we can conclude that uh, one important thing is that we can uh, pre-training on multilingual settings kind of becomes essential uh, for downstream tasks efficiency, like machine translation. We have seen +2, +12 blue points for low resource settings and +5 for document level tasks. So these two are the new state of art performances that this has shown. Also, we have seen zero shot and unsupervised translation, which earlier model did not show. In future work, what this paper shows is that this can be scaled to multiple languages. So we have just trained it on 25 languages. Maybe we can train it for, let's say, all the languages in the world, uh, which would be a future task. Efficiency improvement could be one, because pre-training takes a lot of resources, and fine-tuning also takes a lot of resources, which can be indeed looked into, and efficiency can be brought up, and the training time could be brought down. And another thing could be is that we could look into other type of architectures and not just stick to BART. Thank you.